Hey folks, this is section 3.5, and what I would like to do is go through just some terminology that we have in this section. It'll save us some time and not actually having to talk about it in class, and not only that, you will have the ability to be able to rewatch this in case you forget what a certain term means. So the first thing that I'd like to point out to you is that I have here what's called a higher order function or a higher degree function. These are called polynomials, and I have a very, very ugly polynomial that I've given you an example of. So far up to this point, the only thing that you guys have dealt with is quadratics, and that's about as high as your functions got, was having that square term being the highest power that you've seen. So this one's pretty ugly, but I'm going to use it and refer back to it as I go through some of the terms in this particular section. So the first term is term. What is a term? These are parts of my polynomial that are separated by pauses and negs. Pause and negs. So if you would look up to the very ugly example, how many terms do you see in this example? Go ahead and fill in the blank. The next definition is degree. This is the highest power. The highest power. In our quadratics, the highest power was always a 2. So a quadratic has a second degree, or a degree of 2. So as you look at our ugly example, what is the degree in this particular example? Fill in the blank. Next, we have the leading term. Now, we've already said that there are many terms. Terms are what's separated by pluses and minuses. The leading term is the whole entire term that contains the degree. So remember, degree is the highest power. So if you'll look for the highest power, the whole entire term that has that power in it is called the leading term. What is the leading term in this example? Fill in the blank. A coefficient. A coefficient is the number multiplied by the variable. The number multiplied by the variable. Now I have several coefficients in this particular example. What are some of the coefficients in this example? Next, we have the leading coefficient. Now we've already dealt with the leading term, where that's the whole entire term that contains the degree. What is the leading coefficient? Well, this is the coefficient inside the leading term. Inside the leading term. So in our ugly example, what is the leading coefficient? Fill in the blank. Definition number 6, and the last definition for this particular section, the constant. This is the number that doesn't have a variable with it. It's the number that does not have a variable with it. So as you look in our example, what is the constant in our example? Moving on to some more concepts here, some properties of polynomials. Polynomials always have a domain from negative infinity to positive infinity, all real numbers. And again, think about the quadratic. The quadratic is a specific type of polynomial, and we knew that the quadratic always had a domain of all real numbers. This is not a surprise. Also, polynomials are always going to be continuous. There will be no breaks in the graph, no open holes in the graph. And then thirdly, they're always going to be smooth. They don't have any corners, no corners, like the absolute value v graph. That is not a polynomial because it's not a smooth graph. Some specific polynomials that we have, the quadratic, we already know has a degree of 2. Think back to the parent cubic function, the parent cubic, and that has a degree of 3 because the highest power is 3. A quartic, we don't usually use that word very much, but a quartic would have a degree of 4. Anything else past 4, we don't really have a specific name for it.